In this video, we'll quickly recap relational databases and SQL. When we record data in a relational database, we find that data often has relationships. For example, a club has a manager. A player plays for a club. A club has many players. These are all relationships that can be expressed in data that is written to a file, and we would typically use the ID values. It can be difficult to retrieve efficiently two or more items of data that are related to each other from a flat file. So we find that relational databases can be quite efficient and helpful. Here we have some relational database tables. Here we've got a club table and here's a manager table. Each one of those tables represents an entity, the conceptual entity, and each row in that table will represent one actual entity. So here in the club table, we've got 3 rows, one for each club that is represented in the table. And over in the manager table, we've also got 3 rows, 3 managers. Relational database tables are linked by relationships, hence the name relational. And we can represent those relationships in an entity relationship diagram. So here we've got the relationship, a club has a manager. Here's the club table, here's the manager table, and there's the relationship between them. We tend to use crow's foot notation, and you'll see why in a few moments. So this is the table name. In the bottom section, we've got the attribute names. And in this middle section, we've got an attribute that represents the primary key. So that notation, PK, means primary key. And it identifies a column in the table that will identify uniquely a single row in the table. In the manager table, as well as the manager attributes, and there's the primary key for manager, we've also got a club ID, and this is known as a foreign key because it identifies a column that holds the value of the primary key over in the club table. And that's what forms the relationship, the fact that there is a value in this column that relates to a primary key value over in club. We draw the relationship as a line. And these symbols here indicate 0 or 1. So if we were to stand on the club end of the line, we would see that a club has got 0 or 1 manager. And if we stand on the manager end of the line, we see that a manager has 0 or 1 clubs. And so here's the data represented again. So we can see that each row represents one entity in the table. The primary key value of the club is a foreign key value in the manager. And so this quite naturally tells us that Phil, whose ID is 3, is a manager for club number 1, the A team. Likewise for Jan, but she manages club number 2, our team. And Graham doesn't at the moment have a club. Now in the crow's foot notation, we can represent a one-to-many relationship, and that's the symbol for it, and you can see that the 3 prongs look like the foot of a crow, hence the name crow's foot notation. And this diagram now tells us that a club has 0 or more players, and so one club can have many players. Therefore, in the table here, there could be many player rows, all with the same club ID, because there could be many players with the same club. And so we get a situation like this. Now, let's take a few moments to identify Rosie's manager. Here's Rosie. Rosie is in club 1, which is this A team. And as we look down the managers, we find that Phil is the manager for club 1. Therefore, Rosie's manager is Phil. Now, when we've got a relational database, we are able to manipulate that database using SQL, Structured Query Language. And there's also another language called DDL, Data Definition Language. And we can use these to create and delete tables, insert new rows into a table, update existing rows, delete rows, and retrieve data. Retrieving data is typically known as querying. So I'm going to very briefly review the syntax for each of these main commands in SQL or DDL. I'm going to call it SQL as a sort of an umbrella term, but officially this, for example, is a data definition language statement, but we'll just call it SQL. So if we want to create a table, there's the format, create table, and then some table name. So create table club. And then in the brackets, we specify the column names with their data types and any constraints. So here we've got club ID of type number, and the constraint is primary key. For club name, it's a string, so we call that varchar 20. That's its length, the maximum length. And the constraints are that it cannot be null, so not null, and it has to be unique. And that will cause the database management system to make sure that any values or any rows that we put in will match these constraints. If we want to remove a table from the database, so delete a table, we will drop table. Now that's not the same as deleting rows, as you will see in a few minutes, but drop table will remove the table entirely from the database. If we want to insert data into a table, then we'll insert a row using insert into, then the table name with any columns that we're going to populate, followed by values, and the values that are going to match these columns. So for example, we're going to insert into club. Now we're not specifying any columns here because we're going to provide a value for every single column. So we're going to insert into club the values 1 and 18. Notice that a string has single quotes. We're going to insert into player, but only in these two columns, player ID and player name. And then those are the values for those columns. If we want to update a table, that is update a row within the table, then we will update, give the table name, and then set whatever the column name is equal to the new value. So if we update club, set club name equal to top team, if that's all we had, if we did not have this where clause, then those two lines on their own will cause every single row to be changed so that the club name becomes top team. But because of the unique constraint on the club name, that would be a problem. But generally, if you don't specify a where clause, every row in the table will be updated in the same way. And that's why we would tend to use a where clause. So now we're going to update the club. We're going to set the club name equal to top team, but only where there is a row whose club ID is equal to 1. And we're going to update player and set the player name equal to James, but only where the player name is equal to Jim. So it might be that there are several players with the name James. Let's say there are 4 players with the name James. This statement will update all 4 rows. When we want to delete rows, and this is the distinction, we can drop a table, but we delete a row. So we will delete from whatever the table is. And if we don't have a where condition, that will delete every single row from the table. Whereas if we put in a where clause, that will identify which rows are to be deleted. Delete from club where club name equals top team will delete just 1 row. That is the club with that name. Delete from player where club ID equals 1, that will delete just 1 row. Delete from manager will remove every single row from the table. The table will still exist, but it will have 0 rows. When we want to query from a single table, we select whatever the column names are that we want to get hold of from, and then the table name. Now if we leave it just at that, like we do here, select star, that means every single column from club, that will return every single column from every single row in the table club. If we specify a where condition, then that will limit the returned values to be only those rows that match that condition. So for example, select player ID and player name from player where the club ID equals 1. So it's only going to return those players who are associated or related to club 1. So if there are 5 players in club 1, that will return 5 rows. We could also do an order by, and that will cause the queried rows to be ordered according to the list that is provided. So if we want to order by player name, that will then give us an ascending order of player name. Sometimes we want to query 2 tables at the same time, in which case we will use a join. So we'll select the column names, and these will be names from both tables in the query, from first table name, join second table name on, and then some condition which will identify how these two are to be related. So for example, we're going to select the club's club ID, the club name and the player name from club join player on, and here's the condition. That's the primary key in club equal to this foreign key in player. So we're going to select from club join player on club ID equal to player club ID. And that will then extract these 3 columns from those 2 tables, joining the rows from the 2 tables that match this condition. And we can take that joining a step further. We could query 3 tables, which will require 2 joins. So we're going to select whatever the columns are from table 1 joined to table 2 on some condition, and then that being joined to table 3 on some other condition, with an optional where and an optional order by. So we're going to select the club's club ID, the club name, the player name, and the manager name from club, join to player, where or on club ID is equal to player club ID, and then join that to manager on club ID equal to manager club ID. We can auto-generate primary keys rather than having to know what the next value for primary key is. We can get the database to do that automatically. And in MySQL, when we create the table, one of the constraints that we put in on the primary key is to say auto increment. And then we don't insert a value for club ID. That will be automatically generated whenever we insert a row into the table. If we want to identify a foreign key, as we are in player, then having listed all those columns that we're defining in the player table, we then specify the foreign key. So we're going to say that the foreign key club ID references the club table club ID. Without this foreign key constraint, there is actually no official relationship between the 2 tables. So we have to put that in if we want officially to have a relationship between the 2 tables. And putting that in will then ensure that the database will check. Every time we insert a row to the player table, it will check that the club ID value matches the primary key of a row in the club. And if we try to delete the club, it will check to make sure that there are no players that are related to that club. And if so, it will throw up an error to say, sorry, you can't delete this club because there are players. So that's a very quick review of some of the basics of SQL. You should, of course, take time to look at the SQL syntax for whichever database it is that you are using and make sure that you are familiar with it.